third video for Chapter 2 is going to focus on one last way to display numeric data. And that last way is with a stem plot or a stem and leaf plot. So far we've looked at dot plots and histograms as ways to display numeric data. Third and final way is the stem plot. In a stem plot, the numbers from the numeric data are divided into leaves, which is just the last digit, and the stems, all the preceding digits. This type of plot, just like the histogram, is useful for larger data sets. We sort of group them together into bins with the stem like we did with our histograms. So in an example from our textbook, this table shows the literacy rates for females and males in Islamic nations. We're just going to focus on the female percentages. Right now, it's organized alphabetically by country, but the data we're looking at, these numbers, are not organized in any meaningful way. We can't see what's typical, what's not typical, what the pattern is. So we can use a stem plot in order to organize and display this data. If I look through all these percentages, the lowest that you'll see is 29%. So this 29 is represented this way. This 2 is my stem, and the 9, the last number here, this is my leaf. There are no other numbers in the 20s, so I can move on to the next stem, which would be 3. I'm looking for numbers in the 30s. I have a 31 for Bangladesh and a 38 for Morocco. So in the 30s, we've got a 31. I put a 1 here, and I put an 8 for Morocco. I would move to the 40s next. Egypt is at 46, hence the 6 here. I would move to the 50s for my next stem. But note, 50 is blank because there are no female percentages in the 50s. So just like a histogram, we would leave a gap here, and we'd move to the 60s. So we've got Algeria at 60%, then we have Syria at 63, and Tunisia at 63, so 0, 3, 3. Moving to the 70s, there are 4 countries. There's Iran at 71, Libya at 71, Saudi Arabia at 70, and Turkey at 78. Now notice in the stem and leaf plot, it's not 1108, but it's 0118. These are always ordered from smallest to largest. So I started with the 70%, 71, 71, 78. For the 80s, there should be an 82, an 85, and an 86. Not necessarily in that order, but there should be an 82. There it is, Lebanon. An 85 at Malaysia, and an 86 at Jordan. And then there are 3 countries at the 99% mark. And so we can see, well, female literacy rates in Islamic nations range from 29% all the way up to 99%. We can see that quickly in the stem plot, more quickly than in the table. As well, we can see that most of the countries have literacy rates at 60% and above. Very few get below that 60%. Only 4 countries compared to all the countries down here. So we can see some patterns quickly from these stem plots. The last thing I want to do with stem plots in this video is make our own from a set of data to see how helpful this can be. So here I have the weights in pounds of a random sample of 14-month-old babies seen by a pediatrician. We want to construct the corresponding stem plot. So it's not in any order. I can't see, well, what's the lowest weight, what's the highest weight without sorting through. I can't see what's a typical weight for a 4-month-old baby. So I want to organize this with a stem plot. If you look through this, the smallest numbers you see are in the 11-pound range. So my starting stem is going to be 11 point something. So I want to see, well, how many 11s do I have? I've got an 11.4, an 11.4, and an 11.6. So I'd have 4, 4, 6. And I'm going to scratch these out as I go through, making sure I get them all, making sure I don't miss one. Note that there are no commas. Then I would move to the 12-pound babies. Just combing through, I've got a 6, a 0, a 6. I don't want to put 606. It needs to be in order from smallest to largest, so I'm going to put 0, 6, 6. And mark out these 12s. Next would be my 13-pound babies. There are no babies that weighed 13 point something pounds in my data set, but I still mark 13. It needs to be in order here. Then we'll move to 14. Quite a few 14s. We've got 1, 0, 9, 5, 8, 6, 4, 8, 9, and 3. So we're going to put these in order from smallest to largest. The smallest will be a 14.0, so I'll start with my 0, then a 14.1. There were no 14.2s, but there was a 14.3. There was a 14.4, 14.5, 14.6, and all I see left is an 8, a 9, and a 9. Oh, there were actually 2 8s. Let me throw that extra 8 in there. So 6, 8, 8, 9, 9. 8, 8, 9, and 9. All that's left are some 15s and some 16s. To fill those in quickly, I've got a 15.0, a 15.6, 15.7, and a 15.8. All that's left are 16s. You can see there's a 2, a 4, a 7, and an 8. With that, I've marked out all the data. And so I've got my stem plot. And I can see the pattern here. I can see, well, most 4-month-old babies weigh somewhere between 11 pounds and 16 pounds. I see there's some variation. Not every baby weighs the same amount. I can see the most typical weight, the one that shows up the most, is the 14-pound mark. So that's where most 4-month-old babies will be. There were no 13-pound babies in my sample. That doesn't mean that there aren't 13-pound 4-month-old babies out there. It just means we didn't have any in our sample. That's some variation that we could see. But it gives me some patterns as to what's going on with the birth weights of these babies. So we'll wrap this video up